Dear participants, it's a great pleasure for me to welcome all of you to the third BASRAN webinar with the title Wetlands and the Baltic Sea Environment. My name is Gun-Marie Östedt Axelsson, and I'm the Swedish representative in the BASRAN board. I'm a member of Stockholmskans Tull Rotary Club in Rotary District 2370, where I was the district governor in 2019 to 20. It was when we, inspired by the Finnish districts, have started our Save the Baltic Sea project. I'm just now standing on the island of Värmdö in the Stockholm archipelago along the Baltic Sea, together with the organizational team Anders Tickan, who is IT responsible in our district, and Sven Rudberg, who is our moderator today. Both are from Värmdö Skärgård Rotary Club. I really hope that you will enjoy our webinar today and that you will be inspired by the speakers, as our goal is to engage Rotary clubs in the 9 countries around the Baltic Sea to take local wetland initiatives. Once again, welcome. Please, Sven, the word is yours.
Thank you, Goya. Good morning to you all. As an officer from the Royal Swedish Navy, retired after 40 years of service, I'm very happy to be here to promote the Baltic Sea. As you have seen from the program, we have 2 parts. First, we will listen to 3 researchers from Sweden, Finland, and Poland. They will guide us from challenges to the Baltic Sea over to wetlands, which is the theme of today. Please show your name on the screen and keep your mic muted during our webinar. We will have time for questions at the end of the 3 presentations, but don't forget that you have to put all the questions through the chat. During the 20 minutes break that will follow, you will have a chance to listen to music, especially suited for this webinar. And after the break, we will go from sounds to things and listen to 2 examples of wetlands, one showcase from Sweden and another from Finland. But first, let me introduce Mark Krawczynski from Poland. Please, Mark.
Thank you very much. A very warm welcome to all our participants, including all our enthusiastic members of the Baltic Sea Regional Action Group from 9 countries, called BASRAN for short. I am Mark Krawczynski from Poland, and I am the chair of BASRAN since last October. I'm also an architect and a composer, as well as past assistant Rotary Public Image Coordinator for Zone 18. We are here today because we all care for our Baltic Sea, and we all want to be proactive. We cannot simply wait for a magic wand to be waved by someone else. We all have to take part in this. We need to be people of action and to inspire others to build public awareness about the condition of our very beautiful but very overstressed Baltic Sea. I'm very pleased that through BASRAN, we can connect and integrate people beyond borders and look at the best scientific proposals for many countries. Then we can discuss, compare, and suggest what might be the best solutions without political impositions. I believe that making recommendations and decisions based on the latest scientific knowledge is the most effective way to proceed in order to achieve effective results as quickly as possible. I feel most inspired by the fact that BASRAN is growing in membership and that our enthusiasm is increasing as we grow. I hope you all feel the same way. Thank you all for being with us. And now, may I introduce to everyone Rotary International Director Peter Kyle. Thank you.
Ladies and gentlemen, I'm delighted to have this opportunity to offer a few brief remarks on the subject of enhancing the global stature of Rotary. We take great pride in the scope and breadth of our international footprint, but we know that we could and should do more. So, last November, the Rotary International Board adopted a 3-point program to enhance Rotary's global stature. The board recognized that this would be a 10-year initiative and affirmed its commitment to a long-term thought leadership development process. Pursuant to the 3-point program, the board has agreed to enhance Rotary's global stature by building an approach that, firstly, establishes a global thought leadership platform, increases our impact. Secondly, activates strategic regional engagement, enhances participant engagement. And thirdly, identifies target organizations and entities for expansive relationship building and outreach, expanding our reach. At subsequent meetings, the Enhancing Rotary's Global Stature Task Force identified 3 key work streams. First, peace and refugees. Second, the environment. And third, basic education and literacy. Let me now say a few words about the BASRAN initiative. I was so impressed to learn about this cross-border cooperation between Rotarians in the 7 countries that surround the Baltic Sea. This is exactly the sort of environmental initiative that Rotary seeks to encourage. It is both locally and internationally based. It directly impacts the livelihoods of millions of people, and it will provide opportunities for all 2,000 clubs and the 70,000 Rotarians who live and work in the surrounding areas to come together and contribute to improvements. May I commend the organizers for arranging this webinar. You have assembled a very impressive lineup of speakers, and I wish you every success in your discussions, and I look forward to learning of ways that Rotary and Rotarians can continue to support this very worthwhile initiative. Thank you.
Now you've learned something about BASRAN and Rotary engagement in the world. So let's go back to our theme of today. It is a great pleasure for me to welcome Her Royal Highness Victoria, Crown Princess of Sweden, who would like to bring her greetings to the participants. Please.
Thank you, Sven. Dear Rotary members around the Baltic Sea, for many of us living in the Baltic countries, the sea is so much more than a mass of water. With its sensitive marine ecosystems and its unique flora and fauna, the Baltic Sea is a source of life and livelihoods. It is where we go to find peace and to make memories. But as we all know, our sea is under tremendous pressure from eutrophication, pollution, and overfishing, to name just a few of the major threats. I am pleased that Rotary is summoning its strong network to protect and restore the Baltic Sea. And I want to thank all of you for putting service above self. Ladies and gentlemen, wetlands have a unique biodiversity and an amazing ability to purify water. They are vital to the future of the Baltic Sea. It is my hope that today's webinar will inspire Rotary clubs all around the Baltic to take local initiatives in order to build and maintain new wetlands. Dear Rotary members, thank you for your commitment and the best of luck with your continued work.
Thank you, Crown Princess Victoria, for your encouraging words and for your strong engagement for our environment, not least our Baltic Sea. Now over to our scientists. First out is Jens Olsson, researcher at the Department of Aquatic Resources, Swedish University of Agriculture Sciences. Jens is working with fish and ecosystems in the Baltic. His title is The Baltic Sea in 15 Minutes. What is its status and what can be done for future generations? Please, Jens.
So, hi everyone. Thanks everyone for inviting me to give this presentation. So I'm going to dwell a little bit about the scientific perceived status of the Baltic Sea, focusing on the footprint from us as humans, and also how it affects life above and below water, and also some recommendations what we can do for safeguard of a living Baltic Sea for future generations. So many of you are very familiar with that the Baltic Sea is a eutrophied sea. It perhaps not as bad as it looks all over, as it looks in this picture, but it's bad. And this is a cause of us human activities on land, as agriculture, sewage treatment plants, and industry releases of nutrients to the Baltic Sea. But there are signs of improvement and positive signs. In many coastal areas, there are signs of improvement where the bladder wrack, which is grows deeper in water and the water gets clear. And this could be attributable to a decrease in the load of nutrients, nitrogen and phosphorus, that we put in the Baltic Sea. So here you can see plots over the input of nitrogen and phosphorus to the Baltic Sea during the last 100 years or so. And the green line denotes a level below which is desirable. And as you can see for nitrogen, for the waterborne in green, here you can see we are below the desired level. And for airborne, we are almost there. And phosphorus, we're still not there, but it has been drastic decreases. So it's really good. But one of the consequences of having an excess of nutrients is that we get anoxic, oxygen-free bottoms, as you can see in this map of oxygen bacteria that can live under anoxic conditions. So the amount of oxygen-free bottoms in the Baltic Sea has tripled during the 2000s, and the black parts of this map show the extent of the oxygen-free bottoms today. And currently, it's an area bigger than Denmark that is oxygen-free in the Baltic Sea, and this, of course, affects wildlife and animals and plants negatively. Humans have also, through our ways of living, have also loaded the Baltic Sea with hazardous substances, so chemicals and toxins. But when looking at the classical ones, those mainly coming from industry that we have known for long, a lot of them are below the threshold desired today. So those are the ones in green here. But there's still some classical ones that we have monitored and measured for a long time that still are above the threshold level, as flame retardants, mercury, and TBT. But one should bear in mind that we're only measuring a fraction of the chemicals out there. And there's a potent cocktail or mixture of chemicals in the sea that potentially affects the wildlife. But this shows that when we take action and stop using some chemicals, we see improvements. Everyone is aware, given the release of the newest IPCC report early this week, that climate change has an effect on humans and ecosystems worldwide. In the Baltic Sea, is one of the fastest warming seas in the world, and it has been warmer. It has become warmer in the past 30 or 40 years or so, as you can see here in gray. And the projections, depending on how fast the globe will warm, tells us that the Baltic Sea will be warmer, up to 3 degrees it could be within 100 years. And this have a strong effect on the animals and plants living in the Baltic Sea. Salinity is also a thing that could change as a cause of climate change. Salinity is really important in the Baltic Sea since it's an environment of a mixture of marine and freshwater species. But we're not too sure what will happen with salinity in the future. So depending on how warm it gets. So you see this red and yellow areas, that's the uncertainty of the projections that scientists made. So it might be less saline, but it might also be no change over time. One of the consequences of increasing water temperature is that the ice sheet that usually or has been covering the Baltic Sea during winters is retreating northwards. And as you can see in this modeling and projections, you can see within the end of the 2000 decade or 2000s, you can see that the ice will likely only cover the uppermost part of the Botnian Bay. And this has strong effect, for example, for the ringed seals that they give live birth to their pups on the ice. Without ice, there will be no ringed seals in the Baltic Sea. Another thing that affects the Baltic Sea is the invasive species that are not native to the Baltic Sea and that are introduced by humans, either by accidental release or intentional release, or release from when big ships clean their ballast water tanks. So here is a plot showing the increase of arrival of alien species in the Baltic Sea since the 1860s. And you can see there's been a sharp decrease following the 50s, and continuously new species are arriving, impacting the native species that we have in the Baltic Sea. Something that people perhaps don't think so much about is that we also cause a loss of habitat of the species. This is a typical coastal bay in the Swedish side of the Baltic Sea, where, for example, perch, roach, and pike and other fish species and a lot of birds and also underwater animals live, thrive, and recruit. By putting up piers, docks, harbors, as we humans do in this very shallow bays, we affect the recruitment habitat of these species. So in this plot, you can see the proportion of habitat, how much habitat there is in an area, given the number of shoreline constructions, so number of piers and harbors. And what you can see, the more harbors, piers, and shorelines, the less of habitat it gets for pike, perch, and roach, for example. And an extrapolation in the Stockholm archipelago shows that 1 to 2% of available habitat for these species is getting lost every year, and has been done so for the last 30 or 40 years. So we estimate that 30 to 40% of the available habitat has been lost to these species. And with a rate of 1 to 2% per year, if you project that in the future, we'll see that won't be much habitat left in a couple of years, a couple of decades. So what about how does this affect life below water? So Baltic Sea is a unique ecosystem, a mixture of freshwater species as perch and cod, for example, marine species. So it's unique with this mixture. It's quite few species and a simple food web, but still complex. I will dwell a little bit about the fish and the mammals and the birds here in my presentation. So one of the most famous examples and well-known thing is the Eastern Baltic cod. And I think everyone is almost aware of that the Baltic cod is in stress and not feeling too good. So here's a plot from the 50s until now about how much cod there is in the eastern part of the Baltic Sea. You can see in the 80s, many refer to this as this how it should be, but one should remember that it has never ever been so much cod in the Baltic Sea as in the 80s. Following a strong crash in the populations, we are now at very low levels. And this horizontal line here tells us that the population should be above this level. Otherwise, we have strong risk for declines and no recovery of the stock. So it's the cod is in really poor conditions, and this could be attributed to that we fished a lot during the 80s and 90s. But today, a lot of the cods look very skinny and lean like this, not like the fish on top here, which is found in the Skansen aquarium in Stockholm, where it's fed and is protected from humans and get good water quality. A lot of the cod looks like this today, indicating that it's not only fishing today, it's also poor environmental conditions that are affecting the state of Baltic cod. The most common and numerous fish in the Baltic Sea is the herring. You can see similar plots for two of the stocks of herring in the Baltic Sea. So the central Baltic Sea herring, which is the herring between Stockholm and southern Sweden, one can say, and the Gulf of Bothnia herring that is from Stockholm and north. And you have similar pictures that with this horizontal line is a threshold value which below the population should not be. And for the central Baltic Sea, you can see that the population is clearly below this level. In the Gulf of Bothnia, herring is doing better, slightly above this. And this is mainly attributed to fishing, how much we fish of this species. Not only the populations has decreased, but also the size of herring has decreased drastically. So, and this is a clear sign of overfishing. Not all species going down, fish species, some species actually are increasing, as the three-spined stickleback, which is a species that has gone under the radar for us for several years. But we estimate that the three-spined stickleback, a small fish species, only like 6 to 7 centimeters big, that we don't fish, has increased 50-fold since the 2000s. And there are consequences of this increase of sticklebacks, because sticklebacks, they live in the offshore areas, but also migrate to coast to spawn. They spawn in the very same base as perch and pike, for example. And in this base, they feed on juveniles and eggs of pike and perch. Also, pike and perch feed on adult sticklebacks. But with the increase of sticklebacks, you can see here is a simulation showing the number of bays in the Stockholm archipelago that are now dominated by sticklebacks instead of pike and perch. So they are like a low-cost swarm entering and conquering the Baltic Sea archipelago. The fish at the coast, I talked quite a lot of them. So perch, for example, there's still quite a lot of perch in the Baltic Sea, but there are signs of population decline locally. Another important predatory fish is the pike. The situation for pike is much worse than for perch, and we see a decline in many coastal areas. As in the offshore, not all species gone down. These cyprinid fish, for example, roach, breams, that are not that important for us humans, for foods and for recreation, for example, they are instead increasing in many areas. This could be a cause of the decline of the predatory fish eating them, but also these cyprinid fish, they are favored by higher water temperatures and more eutrophication. Positive signs. The white-tailed eagle has increased drastically over years since we have supported it with food and also reduced the chemicals and hazardous substances that are causing the decline. There's also other birds that are increasing. Common murray, crested grebe, mute swan, cormorants, and terns. Many of these feed on small fish like sticklebacks or are favored by eutrophication and climate change as mute swan. But we see declines in eider duck and gulls, for example. Many of you are aware that seals has increased quite a lot in the Baltic Sea, and this is also a positive sign. Seal health is improving and the stock populations are increasing. So this is a gray seal, for example. We are now well above 40,000 seals in the Baltic Sea, but they get leaner, much more skinnier. That might be an indication of impact of hazardous substances, or that there is too little food to support the population of seals. The last species and animal I will talk about is the unique harbor porpoise. It's a toothed whale, a small dolphin that lives in the Baltic Sea. It's a critically endangered population, less than 500 animals that are found in the Baltic Sea, mainly in the southern part of the Baltic Sea. And the biggest threat to these species is actually fishing with nets, that they get bycaught and drowned in these nets. So I skip this slide and go to my conclusions. So what can we then do with the Baltic Sea to safeguard it for future generations? As I said, the Baltic Sea is stressed, as the Crown Princess said, but it's not dead, and there are improvements, but we still need to do things. So I think the most important thing we could do is to protect the environment. It's always cheaper and more effective to protect the environment compared to restore the environment after it's been degraded. So protection could come that we ban fishing, we protect areas where humans shouldn't be. We shouldn't go there with boats, we shouldn't go there as tourists, we shouldn't exploit it with our coastal constructions. If we are to exploit the environment, we need to aim at long-term sustainable exploitation, rather than, as it is today, focus on short-term revenues to maximize economic output. And when management and when exploiting and managing the system, we need to have an ecosystem-based approach or a holistic approach where we consider that all species and parts of the environment are connected. Climate change, as we are well aware of, are impacting the Baltic Sea. We need to halt it, slow down, so it doesn't get too drastic in the Baltic Sea, but also we need to consider climate change when setting management targets, and also when designing measures and how much we can exploit in the environment. We need to continue to reduce the nutrient input to the Baltic Sea, meeting the targets of the Baltic Sea Action Plan. Of course, we are on our good way, but we need to continue this work. If we can't restore and if we can't protect and utilize the system sustainable, we could restore the ecosystem, as this webinar is about. For example, nature-based solutions as restoring wetlands. One might also consider that we compensate the environment following exploitation. So if we make something in the environment, we could compensate the environment by creating, for example, a wetland or a natural habitat in another area. We need to, it's a lot of up to us as well, since we need to review and consider our consumption needs and behaviors, since how we live our lives actually affects the Baltic Sea. And finally, political will and action is needed, and cooperation. We need to have long-term perspectives in our political decisions. We need regional cooperation, as you are examples of, and consensus needed on how to protect the Baltic Sea. So this was what I was going to present to you, and thanks a lot for listening, and I'm happy to answer any questions later in the questions and answers part of this webinar. Thank you.
For giving us some hope in the end after the first part of your presentation. Now let's go over to Sirpa Kurppa, research professor emerita, doctor of agriculture and forestry, agricultural zoology in Finland. The title is Reducing the Nutrient Load to the Baltic Sea Through Sustainable, Cost-Effective Solutions. Please, Sirpa.
I'm so pleased to be able to speak to you today and get familiar with the Rotary activities. I was working actually up to 2 or 3 years ago in Natural Resources Institute, Finland. So where I retired some time ago, and now on my slides you see the name Elonkierto, which is actually a harvest circle in English. That is an exhibition park and also an association for sustainable agriculture and food. So if you go to a web page and look for Elonkierto, you find what we are working on. Unfortunately in Finnish, but there is a lot of pictures also to show our activity. So my title today is Reducing the Nutrient Load to Baltic Sea through Sustainable, Cost-Effective Solutions. And it's really easy to continue the previous presentation because I also emphasize the importance of long-term approach. Here you see the Baltic Sea, and when we are looking at the sea, it is all around surrounded by land area, and the wetlands between the land area and the sea are most important. But in a long term, it is of course important what we are doing on the land. So because in terms of eutrophication, that is the land area is mostly the source of nutrients and has been the source of nutrients which have been leached to Baltic Sea and causing the difficulties there. We look at Sweden and Finland, which are very much covered by evergreen forest. Then we are looking at the area in Russia and in the Baltic countries, which we have quite a lot of deciduous forest. And then the big countries for agriculture, which are merely Lithuania, Poland, part of Belarus, and of course Denmark. So that is the kind of living habitat which is surrounding the Baltic Sea. When we are looking, I mean, it's self-evident to everybody that it's the biggest role for eutrophication is agriculture. And here on the right, you see the kind of intensity of the land use for agriculture around the Baltic Sea, and the coastal areas in Sweden and Finland cover that, and then the Baltic countries and Poland and strong agriculture in Denmark. The agriculture goes very well with the number of inhabitants. So the areas where we have a lot of agriculture, we mostly have quite a number of inhabitants, or the most dense number of inhabitants. And then we recently, in every country, I think we have been speaking what we should eat. What should we eat? Just should be vegetarians, or should we eat? I mean, a mixture of food, and we have been quite a lot of giving strong criticism to animal husbandry and the amount of animal-based protein we are eating in our countries. And here you can see the trend of animal husbandry from 95 to 2017. So it seems that number of pigs, pork, and number of poultry has been increasing, especially the poultry has been increasing. Pigs actually not that much, but not increasing, but the poultry is increasing. Number of pigs is quite high anyhow, and we know, everybody knows that especially Denmark is very strong in even in international market for pork production. One indicators more which nowadays have been raised is the carbon stock. The carbon stock per country is that kind of describing the capacity of the countries to absorb nutrients and also absorb carbon dioxide from the air, and here is some numbers of that one, and because of amount of forests in Finland and Sweden, and also partially in Poland, and also agriculture in Poland, we see high numbers on those areas. So this is the background. HELCOM is the organization which have very much been working on the Baltic Sea, and they have a quite recent vision of nutrient cycling. Nutrients are managed sustainability in all HELCOM countries, securing the productivity of agriculture and minimizing nutrient loss to the Baltic Sea environment through efficient use of nutrients and cost-effective nutrient recycling. So certainly in the last few weeks, also the security for agriculture and our own food has gained more and more focus, I guess. But that is the vision which has been published before Christmas this year from HELCOM. And I'll very much focus now on nutrient use efficacy and recycling. Which they really, here are the main objectives of this HELCOM vision, and it's modeling on nutrient cycling, reducing environmental impacts, safe nutrient recycling, because safety is important there, knowledge exchange and awareness, creating business opportunities, and improving policy coherence. So these are all the objectives, and they have also already been thinking about and publishing the measures how to meet these objectives. And at least in my country at present, there are quite a number of challenges. The cost of fertilizers have increased remarkably. It's not a few percent, it's 10%, it is 50% increase. There is an increased cost of energy, and we know that in harbor post-process, energy in terms of nitrogen is very important. There is this dependence of fossil energy, which is quite questionable, and there are big challenges for farm economy. So we are this type of situation. Now I speak about the nutrient footprint. We have been listening carbon footprint and ecological footprint. I'm speaking about nutrient footprint, and it is the amount of nutrients taken into the virgin or recycled form to the production chain, and it is the efficiency of these nutrients utilized in particular production chain. So you can see on the right the nutrient footprint kind of production chain, and how there are virgin nutrients and recycled nutrients which are coming in, and nutrient emissions and nutrients to side products and nutrient leaching to the right, and the main production chain is in the middle. So that is the nutrient use efficiency, and nutrient use efficiency can be calculated per one single product, which is all through the production chain, or the total to the end of the production chain. And it is the use of nutrients through which are taken in and which are finally kept in the production chain. So that is nutrient use efficiency, NUE. And when we start to calculate this holistic kind of process, it becomes quite complicated. This is actually a simplified picture, simplified flow chain of how to nutrient use efficiency would be calculated. You see there the system borders, the outer border, and some borders inside, and you see the flows where the information is actually taken. What is very often forgotten when we think about nutrient use efficiency in our food, we very often, stop to our food plate. What is the material we eat? But actually, nutrient flow should go further. It should go further from our consumption to wastewater and possible food waste, which we are discussing a lot recently. We should reduce that. But anyhow, it should go further from our institutional waste and from our waste back to environment. And this picture is describing quite a complicated processes which are taken in part to the handling or managing of waste. And how we do that, it depends, it has a big impact. What is the impact actually by these nutrients to environments? Then actually to final numbers, we have been calculated two examples. One is oat flakes, which is quite familiar to us as a oat porridge, and another one is bull beef, for which we have prepared the nutrient use efficiency. Okay, here you can see we start from production of agricultural inputs. We go to agriculture, we could go to food industry with these flakes, supply and trade, consumption, and then to the waste flows. And at the end, you can see that nitrogen footprint from 1,000 kilos of oat flakes and 42 kilos of nitrogen is taken. From that, 55 was utilized by the product, so oat porridge, oat flakes, and 71% in entire production chain. that means that the side flows have been taken into account, and the side flows have been carefully utilized. When we go to phosphorus, which is the other major nutrient here, we end up in a situation that for 1,000 kilos of oat flakes, we have used 7 kilos of phosphorus, and 55% of that has been utilized to the final oat product, and 99% totally. And why 99% totally is therefore then when we manage the wastewater waste, we are able much more effectively use the phosphorus from there, take phosphorus out from the wastewater than nitrogen. Most of the nitrogen is going through, but phosphorus, fortunately, we are able to take off from the wastewater, and
Sorry,
that is
Sirpa,
important.
Sirpa, your time is running out. You have to finish up.
Yeah. Okay. I show another example of animal, and for animal, the situation is totally different. For animal, nutrient use efficiency for nitrogen to final product is 1%. And totally 47, and for phosphorus 0.2%, and totally 74. So it is really important how we manage the production chains, and nutrient use efficiency is one way to handle this management. And still one picture which I want you to focus is that this is not a complicated, simplified system. We have to be holistic, and we have to plan the use of side flows carefully. And we have the point what is important is diversity. Diversity of economy. So diversity is not only important in water and in nature, it is most important in economy to be able to manage this process. Thank you so much.
Thank you, Sirpa. To all of you, don't forget to put your questions on the chat. Our last speaker today, before the break, is Renata Augustyniak-Tunowska, Associate Professor on University of Warmia and Mazuri in Olsson, Poland, Faculty of Geoengineering, Department of Water Protection Engineering, and Environmental Microbiology. The title is The Use of Wetlands for Eutrophication and Environment Restoration. Please, Renata, the floor is yours.
Hello, everyone. It is a really great pleasure to be here with you today, and I hope my presentation will give you some information about wetlands, their role in landscape, and I hope some useful tips for future actions. Then I will tell you today about use of wetlands for limiting eutrophication through their restoration and protection in various circumstances. I work in Poland, in Polish University of Warmia and Mazuri in Olsson, and my work is connected mainly with restoration and rescue degraded ecosystem, mainly lacustrine ecosystem. Few words about global water cycle. Wetlands are an important part of the global water cycle on continents, in continental part of this cycle. And the main role is slowing water runoff from land into the ocean. Assess time of total water exchange in this part of water cycle is within the range from 1 to 10 years. And it is relatively short time, but enough for exchanging the whole water in the all wetlands. And in local scale, wetlands are very important factors regulating water exchange between land and atmosphere within small hydrological cycles. And local modification of humidity and climate is very important for us. A few words about wetland situation in Europe. Wetlands occupy circa about 50% of European area. And in Poland, our wetlands are very often a final stage of lakes evolution. On this picture, you can see a wetland nearby my university. It is, of course, a city wetland, urban wetland, and you can see the most important problem with wetland protection: expansion of human settlements and drying wetland. This is completely new urban area, and of course it expands into the wetland. In Poland, we dried circa about 85% of wetlands until now from the total area of wetlands. But in other European Union countries, a situation sometimes looks much worse. For example, in Germany, it was dried 98% of wetlands, or in the Netherlands, 94%. And it is really big problem because wetlands are very important for water cycling in the landscape. Water, if we have a wetland, of course, water can stay longer in this area than in anthropogenically changed landscape, for example, regulated channels or streams without buffer zones. And these areas allows water to percolate into the ground, renewing the groundwater resources. And this process is very important for protecting us from drought. And swamps locally can modify air humidity in local area, creating, for example, mists, and giving better comfort for biological life. Wetlands are located on the riverbanks, are natural buffer zone during flood events. Of course, wetlands play one of key roles in biosphere because wetlands are kind of ecotone between land and water ecosystems. And it is a very good opportunity to living organisms to occupy specific niches, and of course, because of difficult penetration of people through this area, it is a refuge for wild animals. And this is very important today because people are occupied more and more land, and animals can move to more difficult area for human penetration. And you can see on this picture the most important wetland in Poland, Biebrza swamps, Biebrza river swamps. It is a national park, and it is spectacular, especially this time of the year, because migrating thousands of birds. It is refuge for them, and a good point for further migrations. very important part of functioning wetlands in the environment is also the role of wetlands in a carbon cycle. And the highest amount of carbon in the world is stored in wetlands. You can see this on this graphic. On average, in wetland soils is stored 643 tons per hectare on average. This is really huge amount of carbon, and you can see this. It is the biggest storage among all ecosystems. You can see wetlands and soil of wetlands, of course. And because of that fact, wetlands are very important for climate changes, because drying wetlands is dangerous for climate because carbon is releasing into the atmosphere. And we should slow drying wetlands, and we need re-wet dried wetland areas in order to protect us from climate change. Some information about a very important part of human activity, paludiculture. The oldest use of wetlands is, of course, for food production, not in our climate zone, but and Baltic Sea area, but in other parts of the world, wetlands are very important for food production. For example, rice cultivation. You can see here rice fields in South Korea. I spent some time there, and I saw the rice production cycle, you know, from the spring just water, of course, and preparing rice for growing, and later during summer fields. And this is final product, of course, rice taken from the fields. Of course, we on our area near in outskirts of Baltic Sea use wetlands also for gathering food, for gathering, for example, mushrooms, forest berries. And even my family has a very long tradition gathering of wild cranberries which grow at peat bogs. And I was taught by my mom about how to go to the peat bog safely and where the cranberries grow. Of course, we use it for our health. It is a very important part for preparing special jams from cranberries. And I know that it is popular using of wetlands in countries around the Baltic Sea. Wetlands also can be used for gathering other materials used by humans. For example, cultivation of swamp plants, for example, reed maize, you can see reed maize here, or alder tree, and of course it is a lot of using for these materials. Also, coal peat for energy production can be gathered for from wetlands, and turf and wood for building purposes. Wetlands also plays a role in water treatment on biological way. This is natural ability of wetlands, and it was modified by people for building of constructed wetlands. And nutrients are taken by plant biomass and also plant root system. And plant root system creates habitat for microorganisms active in water treatment, wastewater treatment also. And it is a quite popular kind of biological wastewater treatment. According to American Environmental Protection Agency, What is the wetland restoration? Wetland restoration is the manipulation of a former or degraded wetlands, physical, chemical, or biological characteristics to return its natural functions. Then we have two kinds of wetland restoration: re-establishment, that means rebuilding of a former wetland, dried wetland, or rehabilitation or restoration, repairing the functions of a degraded wetland. And both actions are very demanded now because wetlands are under great pressure from human activity. What can we do for protection and restoration of wetlands? I prepared some proposition for everyone for daily activity of everyone. The most important thing, we need to use less water. It is very important. Our daily habit matters, and we should be aware consumers. And we should choose products with lower water footprint, and it is normal thing to do in our households, and we should be aware about it. You can see if you this is about chocolate. Of course, we should eat less meat, more plant products. So this is a good way for keeping water footprint. And also we should use less, for example, less water, for example, taking bath. We should go to take shower, for example, or comparing to taking a bath, it is much less water for using, and it is good for water protection. About chocolate, we should reduce chocolate using. I love chocolate. It is very sad for me, but chocolate has one of the highest footprint among food. For production of 1 kilo of chocolate, it is used 70,000 liters of water.
Renata, your time is running out, so please.
Yeah. I will end for a moment. Of course, second step, we should use less concrete and asphalt and more green area on our properties. And this is the example of good solutions in our properties. And if we are farmers, we should use less fertilizers and keep small water ponds and wetlands in our fields. And it is of course very important. Another thing, it is creating society awareness. February 2nd is International Wetlands Day, and it is a great opportunity to appreciate wetlands. And we can, for example, organize educational events for local communities, or taking a walk with family and friends to see nearby wetlands, watching birds, plants. And also we can sharing, for example, posts about wetlands in net for increasing awareness about wetlands. And the last slide, where are we now? It is a very important part. In 2009, in the paper of Rockström et al., it was created concept of planetary boundaries for describing human influence on the environment. And you can see the green part, central part, is normal conditions. Normal conditions for Holocene, our geological time. And you can see that biodiversity loss was crossed that border, and also nitrogen and phosphorus. And climate change, it is very important. We should take immediate action for this. But now we have another problems, and awareness about it is rising. This is the fresh paper from 2022, and it is also the boundary for novel entities, which was also crossed. What are novel entities? They are chemical compounds created by humans, and it is very important that products, that chemical compounds has no natural degradation paths, and we should be aware, for example, about plastics, about flame retardants, about DDT, etc. And we should do also immediate action for limitation of these novel entities in the environment. Thank you very much for your attention.
Thank you, Renata. Now over to questions. If wetlands are being dried out to between 85 to 98%, can you suggest how we can reverse this process? We might get an answer from later on this afternoon, but would you comment it with 3 words? What can we do to reverse the situation?
Of course, we need to re-wet dried wetlands. We need to allow water come back to that places, and if we increase wetlands area by re-wetting, of course that will be very good way for mitigating climate change and carbon cycle.
Okay, would you say something, Sirpa, or are you happy with this?
Yes, I of course very much agree. And in Finland, because we have a lot of not so much wetlands, but marsh soils, organic soils, turf soils. So we are discussing about the same thing: how to raise the water level in the forests which are on organic soil to keep the carbon in the soil. So that is important discussion for us.
Another question here: is there an ideal percentage of wetlands around the Baltic Sea? How important is the location of the wetlands within the landscape? Is there an easy answer, or?
In my opinion, it is not easy answer, because we know situation. Human population is growing all the time. And this is more and more land needed for people. And this is very important to manage. The ideal wetland area for landscape. But I show you in my presentation that, for example, European Union should re-wet 15 million of hectares area again, and this is really huge area, and probably that will be a very big challenge for the future.
Okay. I think we have to look the natural history of the area and try to kind of rebuild the wetlands in the areas where they have been some time in history. So to make construct artificial wetlands perhaps doesn't have the same kind of prospect as if we base on history.
Would you comment, Jens, or?
I'll leave it to the wetland experts.
Okay.
I think they have great questions.
Okay.
The answers.
Well, there is another question to the wetland experience. Nutrient use efficiency is very interesting. How could I, as a consumer, choose products with the best NUE when buying products?
Yeah, yes. It is the same thing as carbon footprint. If we turn a little bit or more back to vegetable and plant-based food, we are in a safer side, because when we make the production chain longer, as we do when we go to animal-based protein, there is more and more kind of processes of the production chain which can lose the nutrients from there, and which we then should kind of manage as side flows. The number of side flows, if you kill a calf, you get a lot of side flows, leather, blood, intestines, different parts of the cow which you don't eat, and these are side flows, and we are ending up in a mass of management challenges with these side flows. But if you eat a carrot or if you eat a pea soup, it is directly a protein from a plant, and it's much more easy to manage that without loss of nutrients. So that is a simple question for that, answer for that.
Thank you, Sirpa. Let's end this part of the webinar with these few words, and I will thank the three of you for interesting presentations. And we will now make a break for 20 minutes and put on some music. So thank you very much, and have a nice short lunch.
Thanks.
Okay, thank you.